Good day, grade 8. Welcome to our science class. We'll discuss the electric circuits for week number 8 of this first quarter. Let me present to you the objectives of our session, which are number 1, to differentiate series and parallel circuits, explain the advantages and disadvantages of series circuit in homes, and differentiate the voltage and current in series and parallel circuits. Last time we discussed about Ohm's law, which is proposed by George Simon Ohm, and Ohm's law describes as the relationship of current, voltage, and resistance. I here stands for current with a unit of measurement of amperes. B is the voltage and the unit of measurement is volts, and R is the resistance with a unit of measurement of ohms. Based on this law and mathematical equation of Ohm's law, what is the relationship between current and voltage? Correct, they are directly proportional. How about the relationship between current and resistance? Very good, they are inversely or indirect proportional. Let me show you the different pictures showing different circuits. Identify which can make the LED light lighted up. When we say circuit, it is a continuous and closed path of an electric current. Do you think this would work? Do you think there is a continuous flow here? The flow of electric current must be from negative terminal to the positive terminal of the source or vice versa. But in this picture, what do you think? Very good, it will not work. Next, how about this? Let us have the idea again about the flow of electric current, which must be from negative terminal to the positive terminal of the source or vice versa. But in this picture, what do you think? Very good, it will not work. Next, how about this? The connecting wire is connected on both sides of the load and both terminals are connected through the wire and the light. Would this work? Great. This would work since both terminals are connected and we have wires connected to the bulb, therefore it will work. We call this circuit as closed circuit. A closed circuit is one that is complete with good continuity throughout. While this picture show open circuit, and it will never make the LED light up because the circuit is not closed and there is a gap for the electrons to flow. When you say open circuit, it is one where the continuity has been broken by an interruption in the path for current to flow. Question: what type of circuit makes the LED bulb lighted up? Correct, it is the closed circuit. Another question is base, or it is the use of the switch in our house. What will be the type of circuit if you will turn on the switch of the light bulb? Correct, it will be closed circuit. And how we make it open circuit? What should we do? Great, we will open the circuit by turning off the switch. And that is one of the functions of the switch in our house, in our appliances, or in our devices to regulate and control the flow of electricity. Now let us move with the schematic diagram. These are the symbols used to easily draw a certain circuit and to easily understand the drawing of the circuit. Here is an example of circuit diagram. In this circuit, what can you see? Correct, there are battery, bulb, switch, and connecting wires. This is an example of a simple circuit. Beside of it is its circuit diagram or schematic diagram. The symbol used in the schematic diagram have the following meaning. This symbol is the cell. The next one is the symbol or the diagram for the lamp. Next is the switch, and the last one is the connecting wire. A simple circuit can be series circuit. The loads are all in a row. They have one path for electricity. And in this animation, we can see that when one light bulb goes out, the other bulbs will go out also. And this will make what kind of circuit? Open or closed? Correct. It will be open because there will be an interruption with the flow of electricity. On the other hand, it is the parallel circuit, which has many paths for electricity to flow. And in this animation, as you can see, when the light bulb is removed, the other light bulbs are still on and lighted up. This is because they have their own path for the source of energy. The difference between series and parallel circuits is that series circuit has only one end or only one end of each component is connected. Example is the Christmas tree lights. While on the other hand, the parallel circuits, both ends of a component are connected. Example is the household lighting. Now, what do you think the advantages and disadvantages of each simple circuits? In series circuit, the advantages are it do not overheat. It is very simple to do. It can easily regulate the voltage. While the disadvantages are cells do not last long and more loads can decrease the current. While the parallel circuit, the advantages are more loads cannot decrease the current. One load is not affected when the other load is defective, and each load receives voltage. For the disadvantages, too many wires are required. Voltage is constant, it cannot increase or decrease. And last, it is possible for short circuit when we have wrong application for the wirings. To measure the current, what we need to use? Correct, we need to use an ammeter and its circuit symbol is this way. This is how we draw an ammeter in a circuit. Whereas to measure the voltage, we use what? Correct, we use a voltmeter and its circuit diagram is this. This is how we draw voltmeter in the circuit. Now, in measuring the current, the total circuit current is equal to the sum of the individual branch currents. In series circuit, current is the same at all points in the circuit. As you can see in our example, all the branches, all the parts of the circuit containing the 2 amperes for the current. And for the parallel, current is shared between the components. Here in our example, the current flow is 2 ampere, but when it comes to the components, since we have 2 components and they need to share the current, so therefore, 2 amperes divided by 2 loads is equal to 1 ampere per load. Now, let's have an exercise. Fill in the missing ammeter readings. Remember, in series current or in series circuit, current is the same at all points in the circuit. And in parallel, current is shared between the components. So let's have this activity. So here, the answer is 4 ampere. How about in this? Correct, it is also 4 amperes. For the parallel circuit, since we have here the 3 amperes for this side, what will be the ammeter reading in this side? Correct, it is 3 amperes. Since we have 3 components here and they need to share the current, so what will be the ammeter reading in this first component or first load? Very good, it is 1A. Since they are all sharing the current, okay, which is 3 amperes, therefore, the last component will also having, very good, 1 ampere. Next is measuring the voltage. Different cells produce different voltages. The bigger the voltage supplied by the cell, the bigger the current. Unlike an ammeter, a voltmeter is connected across the components. Scientists usually use the term potential difference when they talk about voltage. In series circuit, voltage is shared between the components. Like in our example here, the voltage of the source or the dry cell is 3 volts. And in our series circuit, we have 2 components. Therefore, these 2 components will be going to share, okay, from the 3 volts. Therefore, they will be having 1.5 volts for each component. And for the parallel, voltage is the same in all parts of the circuit. So, if the source has 3 volts, therefore each components in parallel circuit will be receiving same amount of volts from the dry cell. Okay? So, if the dry cell has 3 volts, so the components will be receiving 3 volts also. All the components in the parallel circuit. Now, before we end our session, let us answer the following. Explain what happens to the current in a series circuit when there is a break in the circuit. So what will happen? Correct. The circuit is no longer complete, therefore current cannot flow. Next, explain what happens to the voltage across each bulb as more bulbs are added to the circuit. Correct. The voltage decreases because the current is decreased and the resistance increases. To know more about this, you can click the link down in our description box, or you can click the card that you can see in the upper right corner of your screen. Next, in the parallel circuits, explain what happens to the current in each bulb as more bulbs are added to the circuit. Okay, the current remains the same. The total resistance drops in a parallel circuit as more bulbs are added. And last, explain what happens to the total current provided by the battery as more bulbs are added to the circuit. Okay, so the current increases. Now, before I end, let me share to you this quotation from Thomas Edison. All you need to be an inventor is a good imagination and a pile of junk. Meaning, the solution is in our hand. It is in our mindset and the things that we have in front of us. Sometimes we see those things as useless, but who knows? Maybe someday, those things will be used as a solution to the problems that we have. So that's all for today. Thank you so much. Stay safe, stay healthy, and see you next meeting.